All right. So if we have two side lengths and an angle, an included angle, if it's a right angle, we can use the Pythagorean theorem. B squared equals C squared. Okay? Pretty simple. But if I will ask this back to take stuff away. But if we have two side lengths that are 8 and 12, and we know this angle is 110 degrees, how can we find a missing side if we don't have an angle and a side opposite it? Okay?
Well, I feel like that's what you're going to teach us.
I feel like this is where we're going.
Yeah.
Yes. We will learn the law of cosine. If you want to know the whole backstory through it, it very much resembles the Pythagorean theorem, except we have to subtract out. I mean, we would technically subtract out cosine 90. Does everybody know what cosine 90 is?
Cosine 90?
What is cosine 90?
1, 0.
It's 0. So technically, with our Pythagorean theorem, we could subtract out a cosine 90 and it not affect it at all. So some people say, which one came first? Well, cosine or the Pythagorean theorem.
So it's like chicken and egg with like math.
Yes.
But the chicken had to come first. Why would God create just an egg? I think the egg came first. That's true. God would not just be like, day, what was it, 5 egg. I just really don't see that.
Or he'd be like, egg of.
There would be no way for him to hatch out of the egg because it's not incubated.
Yeah.
Okay. So, moving back to the law of cosine, it is not simply just cosine of the angle. We need some other pieces. So the pieces that you use, the A and the B, we're going to do 2 times that AB cosine of whatever angle, if this is C, of angle C.
Wait, what?
Okay? Wait, what?
Is it kind of like parentheses around the a squared plus b squared? And then
Sure.
What is minus 2abc?
Okay. Okay. So Emily, I can see, really wants me to do this. Okay? Here's the formula.
Thousands of questions on my
If you are given a B and a C, this will become A. Okay? And then whatever angles, the sides that you have, minus 2 times the sides that you have, cosine of the angle you have. Okay? So we can put in different letters. They put 3 different equations. If you need 3 different equations.
Why is it minus?
Okay, fine. I'll do it. But I'm going to write these down. Equals B squared plus C squared minus 2BC cosine A. So it depends on what you're given.
BC.
So
Do
it's
I
the
have
same
to-
formula.
It's the exact same formula. It's what you're given and what you're looking for. But notice the C here and the angle.
I see.
A and the angle.
See.
The side length B and the angle B. Okay? So if you do not have an angle and a side opposite it, you have to use the law of cosine to find that one missing side. Okay? Then from there, to solve the rest of it, you can use the law of sine because then you'll have a side and an angle opposite it. So the most you will ever have to do the law of cosine in one problem is 1 time. That's math.
Why can't you just do like the law of sines by cosine?
Because it doesn't work that way. And Emily really wants me to go through it. So are you ready?
Yeah.
I want you to
No.
Okay, good. Because I'm going to put it on a grid. I'm going to draw a triangle. Here we go. Gonna have a triangle, and I'm gonna have it triangle here. Oh, bad line. We'll have it here, then we're gonna have it here. Okay, so we're all gonna pretend
It's another shark fin. Shark.
it kind of does look like a shark fin right now. So,
I hit
so we all have an A, a B, and a C. Okay, so here's a triangle you're given.
Yes.
And I know the length of A, and I know the length of B. And I know angle C. Okay, so I'm just going to tell you, we know those three things. What I do not know is side C. Okay? I was going to use the same numbers, but A is very obviously 5. Should I just say that? Or should I just leave it as numbers, letters, and not do it? Okay, yes, ma'am.
Is there a reason we're doing this on the
Because I want the distance formula,
Oh.
which is just the Pythagorean theorem.
note?
But that's how they give it. That's what they do. If I wanted to find the length of A to B or that little C, okay? If I were to draw a distance here, okay? This is an X, this is a Y, that would be point A. Yes? Okay? So if I have an XY, I don't really even want it to have a number there, but if I had that, could I say C, or, wait, do we remember the distance formula?
Square root of x1 minus x2.
Oh,
Plus.
parentheses, got my parentheses squared.
Squared plus y.
Either way, it doesn't matter. Distance formula. If we were to square both sides, that's d squared equals. Okay, so I'm actually going to write it that way. D squared equals x1 minus x2 squared plus y1 minus y2 squared. Which is kind of the Pythagorean theorem. It really is. Okay? But I don't really know. I mean, I can tell you what B is, but I can tell you what kind of A is. But if I don't know exactly on a coordinate plane what they are, can you find them in trig functions? Pretending we have a circle. Okay? What are the coordinates of A? Don't you dare tell me -4, 4. I know, but I don't. Okay, maybe I shouldn't have put it on a coordinate plane.
Yeah. Wait, why is this so square? Hello.
There we go. It's gone. There.
Why is this still square?
Why is what squared? All I did here, I squared both sides. So I got d squared.
Gotcha.
So that's the Pythagorean theorem. Okay? So,
I've always wondered why.
sorry. Okay, I squared both sides. When I square the right side, it just takes the
I've
square
always
root
done
off.
that, but I've never solved a correlation.
I like that.
Okay. All right. So, we don't know where point A is. Can you tell me the coordinates x and y in a trig function?
I mean, sure, but we can't find them.
Yes, you can. You have a circle. There's a point P. There's a point P. Find the coordinates x, y. It's been on multiple tests. It will come back again to haunt you.
It's the radius.
No. You have to know something about this theta.
We did that little equation on like the
S equals R theta.
That's an arc length. I don't want an arc length. I want coordinates.
Oh,
So, if the radius here is 1, 0, what are the x, y coordinates if I have a theta?
1, 0.
So that's going to be at 1, 0 also?
Sure.
I feel like
I mean,
1, 1. I mean,
so So over 1, up 1,
Or negative 1, 1.
negative 1, 1.
I mean, I don't know how you want me to find it.
Okay. There's a trig function. If we draw a triangle, you have an X, you have a Y, you have an R. Yes? You have an X, you have a Y, you have an R. Yes?
Yes.
But you don't know any angles.
I know angle C. We're gonna put a theta there. I know C is theta. Okay? When I give you numbers, you'll have theta. So, can you tell me over here, if my radius equals 1, what does my X value equal at my point?
1.
No.
Negative
No. Negative 1, it's right here.
2.
It's 2 in our range. It's 3 in our range. Is it ever going to go outside 1? Okay, let's go back to sine theta equals what?
90.
Opposite over hypotenuse. In this triangle, or this triangle, what is my opposite? Y. What is my hypotenuse? R. If R is 1, what do we know? What is sine theta?
Equals y.
So is your Y value what?
Sine.
Y is the sine theta. Can you find X?
X is.
This one go with we're sleepy. Sine is always related to the Y. Cosine is always related to the X.
But you still don't have any numbers.
Okay, I know I don't want numbers right now. We're deriving.
Oh, I thought we were trying to find like actual numbers.
Well, I didn't give you anything. And
That's
the only thing I gave you was that, and I said I shouldn't have at the beginning.
This is 2.
Okay, so this is cosine theta. Sine theta, yes? Yes?
Yes.
Does that ring a bell? That is not brand new information.
Oh, yeah. Got it.
Got it, maybe?
Kinda.
Kinda. So this was, when you did this, it was always sine theta, cosine theta. Whatever your theta is, that's what that point will be related to. Okay?
Okay.
Then, can you find coordinates for here? For B? Okay, we know C, right? We're always putting it at the origin. What about B? Okay?
And 0.
And 0. So we're going over how far our radius is, right? I'm going to make sure I put this one in correctly. Blah, blah, blah.
I think what actual number might be better, honestly.
Okay, you asked for this.
No, yes, I mean, yes, I'll never write it.
So this is the stored Lyman equation? Okay, so we don't have to
Wait,
reproduce this one.
No.
So how do you,
I gave you the equation. We're coming up with it.
how do you get the equation from that?
We're going to go put in coordinates. We're going to have an x1. We're going to have an x2. We're going to have a y1. We're going to have a y2. And then we're going to square them all. We're going to have to FOIL and square them all.
I bet this will be our bonus question.
How many times have you had a bonus question?
Oh, maybe like 2 or 3
Really?
times. Okay, not that much,
In
but like
Trig?
multiple times.
Yeah, we had a bonus question on the. I think we only had like 4.
I did. It was a verifying one, yeah.
Yeah,
Yeah,
because
I
I couldn't figure it out.
Yeah. Okay. Does anybody want to continue?
No.
Do you want to just take my
I'll just-
word and
yeah.
kind of pull out?
I'll
Yes.
just stick with it. Wait, can you finish it but not have
Okay,
us
we just
explain it like you just showed us
Yeah.
what you would do?
It's going to be more complicated, but sure.
Okay. We don't have to understand. Yeah, I just want to see.
So you want to wait? Okay, let's keep going then. Cosine, here we go. The one thing I did not do in a unit circle, the radius is always 1. But here we're not guaranteed this is a unit circle. Our R is not 1. Correct?
Because
So-
if it was a unit circle, then B and A would have to be the same.
B and A would have to be the same. Okay? So what happens with my R? What is R over here? What's the same line that is R in my red triangle? Or B? Okay? So can we put a B there? So if I solve for Y, what's over here with this sign? B. That's what I left out.
Ah, that makes sense.
Okay, that makes so much more sense. So if I put the B, because I always want to go unit circle, B cosine C and B sine theta, B cosine, B sine theta. Because our radius is B. What about B? What are our coordinates here? Wait, how far over did we go? That was actually going to be easy. So we went over A units. Okay? So if I were to plug this in and I want the distance of C, so I'm going to go C squared equals, right? What do we have? Oh, what's our X one? Does it matter? Can I go this one? B cosine theta minus A squared plus Y B sine theta minus 0 squared. Yes?
Yes.
So let's FOIL. Only one of them has to be FOILed. Right? I'm going to have to scoot over. C squared equals. Can you FOIL this quickly?
Not really.
Okay. What's B cosine theta times B cosine theta?
B cosine theta squared.
What is B cosine theta? Is that all in parentheses? Okay, here we go. Thought bubble over here. B times cosine theta times B times cosine theta. I have a B and a B. So should that be?
B squared plus cosine
No.
theta is what?
B times B is B squared. Cosine theta plus.
Right.
Square theta.
Okay, that's just the first term. What's my middle term?
Minus
B.
2AB.
Okay.
2AB cosine theta
A squared.
plus A squared. Okay? What about my last term? That 0 makes it so much more helpful.
0.
No. That
Squared.
means I don't have to FOIL. That this is B sine theta squared, which is
B squared sine.
B squared sine squared.
Haha.
Okay?
Then you just.
Now, let's rearrange. Pull some things together.
You got an equation.
So, can I ask a crazy question?
Can you?
When you have two things that have the same thing with them,
Yes.
what do?
Combine.
Combine them, or can I say B squared parentheses squared plus sine squared?
So they can use that.
Oh,
And
two
then
things that
2
share a
equals
common
theta.
factor we can put together and have that common factor
And
factor
then that
out.
equals 1 because of
This is simply just the number 1.
Oh my gosh.
Oh.
And then what's left?
A squared and 2
Oh, a
AB.
positive A squared and a negative 2AB cosine theta. Yes? So we have C squared equals B squared times 1, which is just B squared, plus A squared minus 2AB cosine theta.
Wonder who's a genius.
Who's Miss Evans?
Spend so much
Did you come
time
up
on
with
this.
this, Miss Evans?
I did. Just in my spare
Just for
time,
us.
this is what I do.
That's probably why you don't watch a lot of TV.
Probably exactly
That's
why.
why you don't get our stuff graded. You're just making up new stuff.
You're just making new math.
Yeah. Woo! Alright, so can we use it? I'm going to tell you probably the most helpful piece of paper in this lesson. I'm on page 322. Page 322. There is a yellow box. talk about that right now. Alright, we are all on page 322. Okay. At the very bottom, don't look at 323.
Alexandria.
Okay. At the bottom, it goes through all the cases. There are 4 cases. The angle where you've got 2 angles. And it's like you're always going to use the law of sine. Okay, that's not anything new. Case 2, we've done. That was 7.2. If you have 2 sides and that angle, that side angle, you're always going to do what we've done. Case 3 and case 4, I have starred. You need to write them down. If you know,
Case 2 and case 4.
side, angle, side. Okay? The side, angle, side. We will use the law of cosine to find the third side. Okay? Next, which I have even more highlighted, you're going to find the smaller angle first. Smaller angle first. Using the law of sine. Okay. How do you know which angle is smaller?
Side is the shortest.
It will be the shortest side. So you're going to use the shortest side. Okay. This one, will it matter once or twice the entire time of the 52 problems you're going to do? It will make a difference. Okay? And you're like, why did I get this wrong? I did it correctly. Because you didn't do the smaller angle first. Okay? Step 3, you find the last angle by subtracting from 180. Okay? If you have side, side, side. Okay, this is a key. I have highlighted. You always find the largest angle first. Using the law of sine. Using the law of cosine. Okay? Then you can find either remaining angles using the law of sine.
So it doesn't matter on that one if you find
It
the
doesn't
smaller.
matter because you've already found the largest one. Bless you. Okay. So there are 2 pieces that I have highlighted, underlined, starred in my book, and these are the 2. Okay. You've got side, angle, side. After you find the third side, you find the smaller angle. If you just have 3 sides, you're going to find the largest angle first, which will always be opposite the longest side.
So what makes why would you what's the instance with finding the small angle? How is that?
Because you have sine. Remember we found the supplement and the complement? The supplement and the original angle and its supplement have the same decimal numbers. Yes? Cosine does not work that way. Because if it's in the second quadrant, meaning if it's an obtuse angle, that decimal number will be negative. Okay? But if you have found a smaller angle, okay, it'll still give you the correct decimal number, it'll give you that one. But when you use the law of sine, and if it had been obtuse and you didn't know it, you found one of the smaller ones, the sine would not give you an acute angle when it should. Okay? And it rarely happens, but it happened to me only the second year I did this, and I'm like, what? Why? I did this right, but I had not paid that close attention to those specifics of those 2. And I'm like, and as soon as we were getting different answers, and it was chaotic, oh, that box right there is kind of important. It might have been the first year. Hopefully it was. Alright, so, they're in your book.
Oh, okay.
Can we work a triangle problem?
Yeah.
Alright, if I give you a triangle,
Miss, we don't have a time.
alright, well then you can work it for homework. Okay, you have a side angle side. Problem. You are going to find little a. You're going to plug it in, and this is still a find all the missing sides and angles. So how many answers should you have? 3. You need to find little a first, is what it says. Find the missing side length, then find the smaller of the 2 other angles. So you're going to plug it in. A squared equals 12.9 squared plus 15.4 squared minus 2 times 12.9 times 15.4 times cosine 42.3 degrees. That is a lot of stuff. I like to see that written out, not just in your calculator. Okay? Then you'll get an a squared equals really big number. Don't give me that really big number as an answer. Take the square root of it. I'm just going to quit the recording.